All right. Hey, listen, welcome back, everybody. With us in attendance today, we got Max over here to our left, Celeste, and then Marcus. Great. Hey, listen, let's go ahead and get started with the lesson. And in this case, I just clicked on, let me click. Marcus, you have to unmute yourself.
Okay.
All right, good. All right, hey, listen, today we're going to go ahead and talk about areas of regular polygons. So with that, Celeste, why don't you go ahead and read this new term?
Apothem?
It's actually called apothem.
Apothem.
All right, good. And then go ahead and read the definition.
The blank the center of a regular polygon to one of its sides.
All right, good. Hey, listen, let me remove the blank. This is new for a lot of people. It's the height. And the thing that's most important you want to keep in mind, it's from the center. So in this case, you're going to discover an apothem once you go from the center, and then you go directly to one of its sides. So let me ask Max this. Max, is that the only apothem that could exist?
No.
No. Give me another one. Let me ask you that. Is that an apothem?
Yes.
Yeah, technically, as long as I move that to the center. Notice that? Okay, now let me go to Marcus. Marcus, is this an apothem?
No,
Why not?
because it's connected to the vertex, not the side.
Is it an apothem now?
Mm-hmm.
Excellent. Okay, so the thing that I love about this is that it's easy to discover what's in the apothem. All right, good. Marcus, go ahead and read postulate 13.2.
If two figures are congruent, then their areas are equal.
No, pretty easy, right? I guess they're saying this in order for you to show that their areas are equal. That means that if you have two same figures, their areas should be the same. All right, now Max, go ahead and read the key concept. This one says the area of a polygon.
The area of a regular polygon is half the product of the apothecant and the perimeter.
All right, good. So Maximus, in your own words, how would you use this equation?
Area equals 1/2 apothecant times perimeter.
Okay, so we find the apothem, and then you multiply that with perimeter, which is over here. All right. Now, let me ask you this. Hey, Marcus, you're going to have to go into your room because I'm hearing an echo. So that means that my voice is projecting over to you. And then close your door.
Okay.
All right, good. Okay, now in this case, we're going to discover that the perimeter, hey, Celeste, if I had to find the perimeter, how would I find it of this figure?
Well, you need to find the side.
Yeah, so basically I had to find everything I'm right now coloring in purple. So once you find out the perimeter, you have the benefit of using that value and putting that in P, and then multiplying with the apothem, and then taking a half, and then you're guaranteed the area. Pretty simple, right? Now let's do this. Marcus, why don't you go ahead and read the area of an equilateral triangle?
Well, okay. So the area of an equilateral triangle is 1/4 of a side squared times the square root of 3.
Okay, excellent. So that means that you only need to find S, and one thing that I love about this is you could find S anywhere on here. All right, good. Now let's get into our examples. All right, so Max, go ahead and read the directions on here in example 1.
Each regular polygon has a radii.
Yeah.
Polygon as shown.
Okay, good.
Find the measure of each number angle.
All right, excellent. All right, Maximus, so walk me through it. How would I find the measure of each of these angles?
First, you look at the apothecant or whatever.
No, but I just want to find the measure of each numbered angle. So like in this case, how would I find the measure of here? Let's start with 1. Now, Celeste or Marcus, can any of you guys know how to find the measure of 1?
So
Okay.
You know the total angle of all the sides combined is 360, right?
Good. Yes.
So we
So
just
I'm
have to
doing-
divide 360 by the 8 sides. So 360 divided by 8, which is
I think they probably have that
90?
figured out for us. Let's see. Yeah, 360 divided by 8. Actually, 45. You see how that shows up right over there?
Mhm.
Okay. So as a result, and let me move the 7 that's here. Or let me move this. Okay. We're guaranteed that this is how you find the measurement of angle 1. All right, good. Now, Celeste, would you know how to find the measurement of angle 2?
Of angle 2.
Yeah. Marcus, why don't you help her out? How will you find the measurement of angle 2?
Well, it's half of 1, so.
Yeah, it's half, because you see how it got cut in half? This is a perpendicular bisector, which bisects also the angle. So as a result, you take measurement of angle 2 is the solution of 45 divided by 2. So you get 22.5. All right, good. Now, Maximus, how do you find the measurement of angle 3?
Is it 45 also?
It's going to be,
Oh,
no,
wait.
because remember,
No, 45 minus 90, it has to be something. I don't know. Oh, wait. Yeah.
no, well, keep in mind, this over here, okay, so we found out that this was 22.5, right? This part. This is 90. So as a result, 22.5 plus 90, or 180 minus 22.5 minus 90 gives you that angle 3 is a result of 67.5. It's going off the idea that all triangles equal 180 degrees. All right, good. Okay, so let's do this one more time to see if it works a little bit better. So we'll start with you again, Max. How would you find the measurement of angle 1 on B?
360 divided by 8.
Well, I don't know if it's going to be 8. Let's count.
8. That's 7.
Oh. Mm-mm.
Oh, it's 9.
Yeah, so 360 divided by 9, right? So this time it's 40. All right, so Celeste, how will we get the angle of 2?
Well, so it's half.
Yes, good. So in this case, 20. And then Marcus, how will we get the measurement of angle 3?
Angle 3. So you would add 40 and 20 and minus that from 180. So measurement 3 would be 170 degrees.
70 degrees, right? Excellent. Okay, good. So now this is going to be important because sometimes we're going to have to use angles in order to find perimeters or apothems. And you'll discover why in the next couple examples. So now let's go ahead and go back over here. And actually, let me remove this for all those that are writing notes at home in regards to this. You can go ahead and see these numbers and copy them down as far as the examples as well. All right, so now let's go back. Now, Maximus, go ahead and read example. Let me go down a little bit more. There we go. All right, Maximus, read example 2. What is this? Read the directions.
Find the area of each regular polygon with again apothecon A and side length S.
All right, excellent. Okay, so walk me through this. How would I solve this one on A?
What does S mean?
S means side length. So it's saying that S is 2.4 inches.
So you do 2.4 around, so it's 1, 2, 3, 4, 5, 2.4 times 5.
Oh, excellent. So you see how it says P right there? So remember, P stands for perimeter. So as a benefit, you'll discover that P is 12. Okay, and so what else are we going to do?
Then you times that by 1.6.
Okay, and then do what?
Divided by 2, or divide by 1/2.
Yeah, because you see the equation? You see how we start 1/2 is apothem times perimeter?
Mhm.
So as a result, exactly what you said, Maximus. 1.6 times 12, and then divided by 2. And then as a result, we'll get 9.6. Ooh, hold on. Let me go back to this. All right, excellent. Okay, so now let's go it. Now let's do, all right, Celeste, lead me. Well, actually, let me go with Marcus. Marcus, tell me how to do B.
Okay. So you would have to first find the perimeter, which is 2.5 times 8.
No, 10.
Actually, it says
10.
decagon.
10?
Decagon,
Yeah, so it's
yes,
going to be 10.
Decagon. Okay. Sorry.
Yeah, so it's going to be 10.
So it'll be 25.
Good. And then what else?
It'll be 25 times 3.8 divided by 2.
Yeah, 3.8 is the bottom. So we go back to the equation, input the values that you just discovered, and then afterwards get the amount 47.5, right?
Mm-hmm.
All right, Celeste, go ahead and do C. How do we do C?
How we do C?
Yes.
Okay. So there's 3 feet on every side,
Mm-hmm.
and this is a hexagon, so it's 6 sides.
Excellent. So what do I do?
Now you multiply that.
Yeah, 6 times 3, right? And that's going to give us our P in the equation, right? Because remember, we're going to use, and then what else do I do?
Then you do 18 times 2.6, and then that half thing. Like
Yeah.
that half.
Mm-hmm. Yeah, because Apothem, and then you divide it by 2. Or you multiply by half, 0.5. So as a result, we'll discover that the solution is 23.4. All right, good. Let me scroll down. Okay, that's it for this page. So now let's go to the next page. All right, let's go. Marcus, read us the directions on this one.
Find the area of each regular polygon write the algebraic answer and then round your answer to the nearest 10.
All right, excellent. So Marcus, how would I solve this one?
I don't remember. I forgot what the equation was.
Well, let me go back up. I went a little too far. Hold on. We're getting there. We're getting there. We're getting there. See, I think if I use my finger, it won't work better. There it is. All right, here's the equation, Marcus. You see it?
Okay,
So what's the only thing I really need?
The side, which is 9 feet. So
9's
you
gonna
just
go
have
in
to
there.
plug that one thing in.
Yeah, that's pretty much. So these equations are pretty easy. So in this case, we plug the 9 in, and then we'll get this as an area. All you have to do is 9 squared, and you get 81. Now, they didn't do anything here because they didn't want to, this is a whole answer, and it's not rounded. So if you do use your calculator, you go round to the nearest 10. All right, so Max, how do I do the next one?
You do the same thing. You just place the S
Yeah.
of 16. Square that.
Good.
And boom.
Yeah. And same thing with the last one. Nothing real special. The only thing that might be not so much new, but you just got to do a little bit more math. Okay, so that gives you examples there on how to do these. Now let's go over to our last one. And Celeste, why don't you go ahead? Oops, no, don't move anymore. All right, Celeste, go ahead. Wait a second. We're almost there. Okay, Celeste, go ahead and read example 5 for us.
Find the area of each regular polygon with the given radius or apothem. If your answer is not an integer, leave it in the simplest radical form.
All right, so Celeste, how would I solve A? You know what? What is the hardest thing that you have about when you're looking at A that is like saying, hey, I want to solve this. I want to give you the solution, but I don't. Well, you need a perimeter, right? Now,
But the square.
if anybody in this group may know this, it may be Max because he's gone through this. What can Celeste do in order for her to get the perimeter?
Say that again. What could I do to get the perimeter? Is there like a
Well,
secret?
Celeste or Marcus or anybody who's
Yo, I know
watching
it.
this. You do,
I know
Marcus? What would you do?
Pythagoras theorem or whatever it's called.
But you need at least
So,
two
wait,
sides,
is that
don't
whole
you?
line 12 or is it just half?
All right, great. So we had a little mishap, but we're going to go ahead and finish up these notes. On this last one, in order to do this last one, we're going to go ahead and use our concept that this is a kite. And remember, just to kind of refresh, one benefit that we have is that a kite is 1/2 diameter, first diameter times the second diameter. So since we know that that is 12, we're given the benefit that this is 12 as well, so it's a total of 24. And on these, we also have the benefit that these are all equal, so this other diameter is also 24. So one thing that I'm able to guarantee you as a result is that it's going to be 1/2 24 times 24, so I could prove to you that our area is going to be 288. Now on this next one over here, one thing that we're going to use is we're going to use the benefit of a little bit of trig. Now for those that, when we went through our special triangles, okay, this is 2x, that is x as you've seen there, and then this was x radical 3. So since we know that the x is 10, then I could go ahead and tell you that that's going to be 10. So as a result, I could go ahead and tell you that each of these sides is 20. So since there's 6 sides, we're going to do 6 times 20, get the perimeter is 120, and then afterwards we'll have the benefit of using 1/2 Apothem times perimeter. So then we'll have 1/2 10 square root of 3 times 220. So my end result is that I'll have 600 square root of 3. Okay, on the last one, to solve this one, okay, we're going to use a little bit of this formula that we know because it's an equilateral triangle. Now, one thing that I'm able to guarantee you is that this is that same trig formula, and I'm taking this from this 60, 30, 90 triangle. This is 30, this is 60, this is 90. And the thing I want to refresh, or one thing I want to remind you that's important, hold on, let me erase it instead, so I don't have to do the whole thing. In red, I'll go ahead and write down that this is 2x, this is x, and then this is x radical 3. So this is kind of like flipped upside down. So the thing that I'm able to guarantee you that this is really 3.3 radical 3. That's the reason this, or let me highlight it instead, this matches this part right here in some respects. But there's 2 of them. So as a result, the 2 of them are there. Okay, so what we're gonna have, so after that, you could go ahead and use your calculator and get the area. Okay, I hope you guys like this edition. Stay tuned for the next episode, and take care, everybody.